Welcome to the SimScale platform. In this tutorial video, we will show you how to set up an external aerodynamics analysis on SimScale. We will create a virtual wind tunnel around a futuristic car shape in order to analyze its aerodynamical behavior. After logging into the platform, the first thing to do is create a new project. You can see in the workspace in the project overview that this one is completely empty. So let's switch to the mesh creator, where we can upload a geometry that we like to analyze. Here we will upload the car shape as an STL file. We could have also used some of the other supported formats such as IGES or STEP. As soon as the upload is finished, we can directly interact with the model in 3D within the viewer. Since it's an STL file, it just has one face, but we won't need more. So we move on to the mesh creation. With a right click on the geometry and choosing the Create New Mesh option, we get a new mesh within the navigator tree. Within this new mesh, we add a mesh operation that further specifies how the mesh shall be generated. Here we choose the automated snappy hex mesh operation for external aerodynamics or external flow simulation. This basically means that we can set up a virtual wind tunnel around this car shape. This operation is kept very simple and automated, so it just has a few parameters to adjust. The most important one is the size of the wind tunnel that you're creating. Here we can see that by adjusting the minimum and maximum points of this bounding box, we can specify the wind tunnel. The next steps are to choose on the fineness of the mesh and on how many cores it shall be computed. As soon as we hit the start button of this mesh operation, it is carried out in the remote computing center. The job status in the lower left always keeps us updated on the progress of the mesh operation. Let's speed this up a little bit. After a few minutes, we have a fully computed mesh. Each job that is carried out on SimScale has a detailed log file that shows you the details. So in terms of cell count and time for the computation and things like that. So let's review the mesh. Hiding the outer faces gives us a better insight into the volume mesh. Here we can see that in the front of the car there is a lot of refinement done and there are quite fine cells. However, in the rear, in the back of the car, there's no mesh refinement done. And here we expect turbulence effects to take place and vortices to appear. So actually there we would need more fine cells. The mesh clip shows it even better that this mesh is not ideal for this type of analysis. However, it was a very automated operation that we used and it took us around 5 parameters to adjust. SimScale has plenty of other mesh operations that you can use, and here we can see as an example, if you do invest a bit of more time, you can take advantage of volume refinements, layer addings that you can add to this mesh and to resolve the critical regions better for this kind of analysis. However, for this tutorial, let's stick to the initial mesh. As a next step, we assign faceheads to this mesh. This basically means that we group some faces of the mesh together to be able to assign boundary condition in a very fast and straightforward way later during the simulation setup. So we create a facehead inlet, outlet, surrounding walls, and for sure the car and the floor, right? Okay, now we're good to go. Let's move on to the simulation setup. We switch to the simulation designer, create a new simulation, give a name to it. The first step in every simulation setup on SimScale is to choose the analysis type. Here we can see that for fluid mechanics there are quite a few available, but we are interested in an incompressible, turbulent, steady state analysis for this virtual wind tunnel. Saving the analysis type immediately expands the navigator tree with all the items that we have to define for this simulation setup. The first item is the domain. So within the domain, we choose the mesh that we just created. The next step is to assign the initial conditions of this steady state analysis. The green dots indicate that this tree item is fully specified. The red dot at the boundary conditions already shows that the boundary conditions are missing. So let's specify the velocity inlet boundary condition. We'll make 15 meters per second inlet velocity, switch to the faceheads, and assign the inlet to this boundary condition. It's important for this analysis type that you specify all the boundary conditions for all physical variables for each phase of the mesh. For this analysis, that's pressure, velocity, and the turbulent quantities, since we're using a k-omega SST model. We will skip the detailed setup of all the boundary conditions because you can review them later, because this project is available in our public library. Let's move on to the numerical settings. The SimScale policy says that you should have access to all the numerical details of a solver run, but they are always chosen intelligently, so you're not forced to assign them or to change them. This simulation is then carried out on an 8-core machine in the cloud. The residual behavior is always updated live during the simulation run. Here we can see the final residual behavior. It's not fully converged, but it's fine for this tutorial. Then you can choose either you are using the integrated post-processing environment, as we can see here, you have filter operations and other things, or you use a local post-processing system, like here ParaView. So you can always download all the results, all the meshes, etc. that you generate on SimScale. Here we can see a streamlined visualization created in ParaView with the results generated on the SimScale platform. This concludes this quick tutorial on external aerodynamics on SimScale. You can review this complete project via our project library. Just sign up and click the green import button in your workspace. Thanks a lot for watching and happy simulating on SimScale.